Welcome to this demo of the Alivio platform. Alivio is a data and AI product that helps disaster relief organizations to prioritize efforts during and after a natural disaster. This is done by providing key information around building damage and vulnerable populations. This is done by aggregating and collecting a bunch of data from various sources such as NASA, XView2 Challenge Dataset, Google Earth Engine, and so on. Let's go ahead and see how Alivio works during a natural disaster. Generally, there will be a team in headquarters or analysts who will provide information back to the ground team to know where to go in the event of a disaster. We'll assume that we are the analysts who are using Alivio to pass on relevant information to the ground team. In this case, let's assume that we as the analysts, perhaps through Sentinel Hub or NASA, have access to live satellite images that in this case, for an MVP purpose, we're able to just take a PNG extract of to then use to provide to the model. We do have long-term plans where we want to use live satellite data directly without the user having to upload snippets or of images and such. So in this case, we can get a lot of satellite images from the gallery section in the application. But right now, I'm going to use some pre-downloaded hurricane images that I've got on my local system. Once I put in the image and the metadata, we can ask Alivio to run a prediction for us. When we start the prediction, Alivio will show us what the uploaded image looks like. As you can see, this is a sample of a satellite image containing a bunch of buildings during Hurricane Matthew. As such, this also contains some metadata with information around how the satellite took this particular photo. But more importantly, it does contain some ground truth with polygons on where the buildings are. We acknowledge that this would not be readily available during an actual satellite situation. But we feel that we can supplement this using a YOLO model in the future. And for now, assume that satellite images come pre-annotated with building data to allow the model to know where to focus on in order to classify building damage better. Predictions usually take about 1 minute per image, and the model returns metrics once the prediction is done. It looks like our model has completed the prediction. In this particular case, the accuracy and the other metrics are derived by looking at the number of buildings that the model was able to classify correctly versus the total number of buildings in the image. Next up, let's take a look at the vulnerability map, where in this case for Hurricane Michael, we're going to show the historical buildings, their damage levels, and their geometries in a map. This provides some basic information around Hurricane Michael for immediate context. You can imagine that as an analyst, I would be getting this as a live feed of information based on how the situation develops. Moreover, we can see the ratio of damage to no damage buildings as a result of Hurricane Michael so far. This is a map of the damaged area over Panama City. Red indicates destroyed buildings, yellow with major damage, blue with minor damage, and green with no damage. While we do see that a lot of smaller buildings do have almost no damage to minor damage, we do see that others have been very badly affected by the hurricane. This is where the prioritization that we spoke about before comes into play, because we would now know where the most damaged buildings are, and if there are vulnerable populations in those areas, then we can focus our relief efforts there first. Now let's take a look at what the demographics and GDP data looks on top of the damaged buildings. This will allow us to narrow down on the most vulnerable areas affected by this disaster. This shows a map with both buildings as well as demographics. We use Uber H3, which is a geographical grid system that uses hexagons across the entire world. The advantage is that we have this uniform layer to map various attributes to, and therefore allows us to view a lot of information at a geospatial level in a highly normalized way. Looking back to the same damage levels, we can see that the population in some of these grids was fairly low, with the GDP per capita as well. As such, this information combined with the building damage allows relief workers to see which hexagons, in this case, or areas need more focus on, and then going more local or microscopically view which areas need relief first. That's Alivio, with more things on the way, such as disaster simulation and much more. We are very thankful and grateful to UC Berkeley, as well as the United Nations World Food Program, for providing iterative value as we built out our solution, and we will continue to do so. You can follow our updates through our GitHub repository, which is all open source, or through our project page on the UC Berkeley site.